Okay, so let's go directly jump into it. I'm going to present today about a project I'm doing at a customer. It's actually an insurance. We are setting up a new kind of data warehouse for a very special a focus on employee data and employee performance. And I thought about using temporal tables and time travel in order to implement it, because for me it sounded like a perfect match, but there had been a couple of challenges, and this is what I'm going to share with you today. So we will start with a very short introduction. There had been talks about the temporal tables and time travel before, so we will skip very fast over that basic stuff in order to have enough time to talk about loading data, joining data, and combining it with BLU in the end, because it's a data warehouse. We do have front ends trying to query it in hopefully a very performant way. So from an introductional part, the warehouses, we always collect data and we build a history. And this might be true for some of the operational systems as well, but most of them are not having a history already in there, so we have to build it. And this can be complicated because keys may be different. You have to maintain the history, you have to build it up. And it also depends on the number of time dimensions you've got. I've seen data warehouses up to 3 and 4 time dimensions, which gets enormously complicated. In most cases, on the other side, I've seen that 2 are quite a good compromise. So between complexity and power of implementation, this is maybe a good choice, and this is why I did this. And when time travel and temporal tables were announced or were included into the product, this was back in 10.1, I thought, well, this sounds like a perfect match for me. This is a data warehouse feature. And it turned out later on I learned, well, it is not actually. It was not meant to be a data warehouse feature. They were really focusing on operational sources that had to store historic data as well, like a contract, like an insurance contract and something like that. So people did a lot of homework to do their own solutions, coming up with trigger-based solutions, application-based solutions, whatever. And this was the original target. But on the other side, I thought, well, I'm keeping a history of data in my data warehouse as well, so why not using it for that? And this is the story about that. Well, what do we have? What have we got? We have system period temporal tables. Cool stuff, because Db2 keeps track of all the changes and data and timestamp information. You don't have to care much about it. It is just working and keeping a history, building up a history. Whenever somebody changes something, deletes something, the history is still kept. This is a system period temporal table. And in Db2, you get basically 2 tables, your base table with the current data, and you build a history table, which looks pretty much the same, and you combine those with an add versioning statement. And this means from the outside, from a perspective of an application, it looks like a single table. From a SQL point of single table, you just query it. On the other side, you have 2 physical tables, enabling you to do different configurations for them, different security for them, different table options for them. For example, because the history table just keeps a history and just gets data added from the current table, I think it's a good idea to alter that history table and to switch on append on, because data is just appended on that. Okay, so you also have different indices on that. Well, that's fine. So it's cool stuff. And it's very powerful. And I really recommend this for everyone, also outside the database world. If you want to keep track of what happened to a table, this is a really good solution, because you don't have to do much about it after you've once defined that. The second option is application period temporal tables. This is where the date or time or timestamp information is provided by your application in the source system or wherever. And it is just taken into your data warehouse. And this is a very important thing for me was, this is the way where you can specify future dates. Let's say you have a configuration table and you want something to happen on the 1st of next month. You don't have to think about system temporal because Db2 will handle it. Db2 will always handle the time when it arrives at Db2. So there's no way to define any future dates. If you need future dates, it's automatically an application period temporal table. And for that, you don't need a history table because all the history periods, the historic periods, are kept in the base table anyway. There's also the option of a combination of the two. So you have a bi-temporal table having already 2 dimensions of time combined with system and application period temporal table. Besides this technical stuff, you get the whole power of so-called time travel SQL statements. And that's the really cool stuff, because it is part of the SQL standard already in the 2011 standard, so quite old, but I guess, and as far as I know, Db2 was the first database implementing this stuff. And it's really, really good. So what I could do is I could select from my table and say, well, looking at the current data, of course, but I could also select from my table and say, wait, how did it look like on the 1st of January this year? You can specify it's for system or business time, depending on what you want to see. We want to see what was the database physically looking like, or logically, if you're selecting the business time frame. On the other side, you can also say, wait, what changes happened in July? This is easy. Just do it from 1st to end of July. Really cool stuff. Standard SQL statements. And it just could be used against that database and that table. In addition to the select, which is of course very, very interesting, you also could do updates and deletes for a certain portion of time, and the portion is a business time. Think about that. Well, an update, you are not allowed to manipulate the dates and times that are maintained by Db2 because it's system time. It's maintained by Db2. It's Db2's responsibility. But you can do it for business time, because business time is the date and time you provided, or your application provided, your source system provided, and you can mess around with that. So you can delete a certain time frame, you can update one. We will see some examples later on in the presentation. So this is really cool, and the access to the history table is completely transparent. You don't have to do it. You can, but you don't have to. Question?
What happens when the daylight time frame
About daylight, well, this is nothing special with it. It's like any other timestamp in the database. So it will reflect in your system time, as your system time is just like a current timestamp. It would be the same what a current timestamp does. You might run into problems now, but you could also you might be able to specify additional stuff like a UTC timestamp, and there are new functions for that. Okay, so as I said, I will just quickly jump over that. So I have the syntax for a business timetable or system timetable or bi-temporal table in the appendix, so you can look it up. There's some additional stuff. Also, how you can see this from a catalog perspective. How can you query the catalog in order to figure out which of your tables are business time, system time, and so on. It's in the appendix. I don't want to spend too much time, otherwise we would not have enough time to go to the other details. And I have to share a couple of more information here, and the next topic is load. And loading in a data warehouse, I mean adding data to the data warehouse, building up a history. So this is not only the load command, it's more, I have a slide on the load command as well, but it's for me, this is the idea of adding data. And we have, if our source system has no history, we have to build a history in our data warehouse. Once we load on a regular basis the data and the delta from last day and from last week and so on into our data warehouse. With this come some challenges. The keys might no longer be appropriate because the unique key in your source system is no longer unique because you have that date, that information over time. So it needs to be extended. Think about that. For extending keys in a data warehouse, we often use so-called surrogate keys, artificial keys, new keys built specially for the data warehouse. This is just done on a frequent basis. There are some reasons to that. For example, you could have, if you're loading a customer table, you could have your customer base in 2 operational systems. Well, don't say this is not possible. I've seen multiple source systems independently managing customers. So in a data warehouse, you want a central idea. You get them all in, and because all the different source systems use different functionality and ideas of how they keep their keys and customer numbers, you want to unify this, bringing it into your data warehouse. So how do we build an artificial key? It needs to be unique. Well, I love identity columns. So identity columns are one way to do this. It will guarantee uniqueness because it's built whenever new data arrives, get a new number, automatically unique, that's fine. But you might hide some data problems because you don't get a primary key violation maybe because you're so unique. So this needs to be really ensured on in your ETL system before that in order not to mess up your data. And there's another but. You need to understand the processing. When we came up in our first test with an identity column, we were really, really surprised, and I'll show you why. So let's start with this example. A simple table, it's a bi-temporal table. Also, I show you just the business time period, and there's a row valid from the 1st of 2005 to end of 2019. It's user ID Hugo, it's ID 1, and just a text. So with that, we do just a regular update. It is a table, so I can do a regular update, of course. I do a regular update, and I update where ID is 1. I set text to do test 2, and it works out as expected. The business period did not change. So regular updates are still allowed on temporal tables. Still work. And now let's do a temporal one. It would look like this. Specified for portion of business time, and the business time is from May 2008 to end of time. What do you expect? What will happen here? Huh? Error. No, this will work. Somehow, magically, it will work. ID 2? Well, let's look at the business period. What do we expect with the business period? We have a business period from 2005 to 19, and now we are manipulating 2008 to end of time. We get 2 rows. We get 2 periods. What are the periods? The resulting periods will be what?
One from 1st of 2005.
Yeah.
Until 1st of, well, last of 2007. Sorry, last of April.
It's May. Yeah. Okay.
And then 1 row for the rest of the time.
What's the rest of the time?
From 1st of May 2008 until end of time.
Ah. Joe? No? 19? Yeah, that's it. Oh, look at this. We got 2008 as 2005, as you said, to 2008. That's true. Well, it's not the last of April because it's including, excluding. So, but your idea has been completely right. And the second is 2008, May 2008 to 2019, end of 2019. Why that? This does not matter at all, because this just gives the time period where the update would happen if data would have been there, but we are just updating a row that existed, and it just existed to end of 2019. So this was not manipulated in that. Okay? This is how it works. Sometimes it's a little complicated. These are the hard questions, really. I got this data, I got this query, what's the result of it? A test is always good, I promise you. Even if you've worked with that, it's not that easy to imagine what is the result of it. But look at this. What happened here? Damned! I got an ID too. Well, this is expected, but the old period got a new ID. The new period got my old ID. Ouch! In a data warehouse world, this is a killer. You don't want to have this. Why that? Well, it seems it was implemented as an insert and update. But they inserted the old period instead of the new. Why that? I don't know. Internal reasons. This is not documented, of course, because this is hidden under the covers. You know, you get a lot of good things with this functionality, but some complexity is hidden under the covers, and that's one of it. Yeah, so why did it get a new one? So basically, you see, you could have left. They decided to not change the business end, but to change the business start compared to this one. But they could have done it the other way around, I guess. Okay. So what about the delete? Oh no, first a little summary slide on that. This means for a non-temporal update, you get a new system start. I haven't shown that because it didn't fit on the slide, but believe me, it will also insert it in the history table. I really hope you believe me. This is what is done in the background for us. The identity is stable. But doing a temporal update, this is what happens. The old row gets a new identity value, and this is something which is very, very, very scary in a data warehouse environment. Second example, let's do a delete. Starting from our result we just got, we have two rows, we have two business periods. Now let's do a delete. We start again with a regular one. So the regular one, well, behaves as expected. Delete wherever this text is task2. Well, this is my ID 2. Just delete it, just gone. It will so be recorded in the history table because it's a bi-temporal table. You won't lose the information. It will just push out to the history table, okay? What about my temporal one? This is the delete I'm going to do for portion of business time, and the portion I specified is beginning of 2009 to end of time. We already learned, well, this end of time is not that important if your data just lasts to end of 2019. It will not open up a new period. But it will manipulate this period, right? The business end, you're right, absolutely right. And that happened. So my new period is 2008 to May 2008 to beginning of 2009. But look at that. Look at that. It got an ID 3. Why 3? Well, 2 was used already, so it's gone. We get a new one, 3. But why didn't we get a new one? It is, yes. Yes, it's a new insert. I did not expect that because the delete, it seems, they implemented the delete as a delete and insert. They deleted the original row, of course moving that. But the moving is not really doing the delete. It's another logic. And they inserted a new one with a new period. Again, this is not what you would like to see in a data warehouse world because your ID, your key, if you have RI and so on, your key has been manipulated. Okay, so identity columns, again, summary, we skip over that. So identity columns is nothing you should look at having the temporal stuff implementing in a data warehouse. What can you do? Well, you could do, instead of timely updates, you could do regular updates. You could do, instead of an identity column, you can use a sequence because it's a separate object. It would not be manipulated that way. Really recommend using sequences in such a case. And for the delete, it could also be implemented with a regular delete and insert. You could do it yourself, basically. How that? Well, this is an effort, but keep in mind, you usually have an ETL tool doing the data processing stuff, cleansing data, selecting data, and moving it over to your data warehouse. And the ETL tool can really handle that logic pretty easily, usually. So you have to move the logic into your ETL tool. And keep in mind, this is really critical stuff if your fact needs to reference the dimension or the other way around, or I would get destroyed by these identity columns. So a little bit more of internal processing is really needed, and I hope you got the idea here. This is not documented. Now, this is the complexity they are trying to hide, and that's good, from the users. In this case, it just has a negative effect, and you have to look at this. And it's the only way I know to see what's really going on if you specify these identity columns, because you don't see the detailed statements. They run in the background, and they do a lot under covers. And I've some more information on that. If for somebody who's interested in some advanced stuff, I have a couple of slides there. Because this part of my agenda is called load, I don't want to skip over that without talking about load with you. So in a temporal table, operations are only allowed if they don't destroy history. For example, you could add a column to their base table, and it would even automatically be added to your history table. That's cute. But adding a column does not destroy anything, right? Removing a column would, so remove column is not allowed. Load with replace is not allowed, because you would destroy history. Okay, just remember that. No operation that would destroy any history is allowed on a temporal table. Besides, you do some extra workaround, and there's a historization switch-off store procedure, which is very useful. Also take care using it, because you are manipulating data at that point, and you could destroy history. So you have to know what you do. But this is a really cool stuff. Ever, as far as I know. Because, you know, what my problem is, I'm doing a test. I'm developing, and all we develop is not perfect from the beginning. Well, as usual. So we do an initial load, and not just once, maybe twice, maybe 3 times, maybe quite often. And in order to be able to do a new initial load, I love to truncate a table, but truncate would destroy history, and is not allowed. If you run this command, it is only valid in that session you're allowed to truncate a temporal table. So for that use case, it's perfect. Okay, switch it off, truncate it, and start again. Okay, but take care. And because if you have a bi-temporal, a system temporal table, you always have generated columns involved. And there are special load options for handling generated columns. Yeah, generated ignore, and so on and so on. And there are also some separate ones for the period. So there's a start timestamp, an end timestamp for system, and there's also a transaction ID column, which is required, really, and it's also a timestamp 12 field. All for system time, it's all timestamp 12, which is the highest, the finest granularity of time you can get in Db2. And you have these options. You can ignore what's in the file. You can say, I don't have it in the file. Or you can say, well, keep what I override from the file, whatever is in your table. And it is pretty much the same as the generated ignore, but it's called period override, or missing, and transaction missing, and so on. Okay? So these are just modified by options you have to use with your load command if you do temporal tables. And don't forget your set integrity. You will need it. Okay, any questions so far? That's for the advanced guys. Who loves explain? Yeah, it's always good. You need this. It doesn't matter if you love it or not. But this is just to show for everyone who wants a challenge. This is some advanced stuff I copied in. You remember the update we just did? The simple update with some search where text is whatever for period of business time. And this is from this simple statement, this is an explain. Wow, looks complicated. Well, it is complicated because we just updated the one column. You see, it has to update the system end, the system start, and of course the transaction start column in the background. This is all hidden under covers. This is all the complexity IBM does for you. This implementation does for you, and you do not have to think about that. Yeah, it does some internal checks. There's even a current temporal row time. I have no idea what it is. It is just to tell you there's a lot of complexity under the covers going on. It is not disclosed anywhere, so that's what's happening. And we also have some checks about our time. You remember we said for portion of business time from to. And it checks if this portion is valid. Does it overlay my data? Is it valid? Because if your portion of business time does not overlay with your data period, it has no effect, right? So it says, does it have an effect? Is it specified properly? Is the start time smaller than the end time? That's what is in there. So a lot of things going on. Internal funct. I also asked John what it is. It's hiding a lot of complexity, and it's not disclosing it even in the optimized SQL statement text. Okay? Just to make you aware, this is the good they handle. IBM is handling the complexity. Okay? Just some ideas. Another fun part is joining. Well, there's this joke. A SQL statement enters a bar. It walks up to two tables and asks, "May I join you?" Yeah, so it walks up to two temporal tables in my eyes, or in my presentation. Have you ever joined temporal tables? Who has joined temporal tables already? Wow, cool. Did you like it? No? Well, I hope you will afterwards. So, in order to make you imagine, because I assume that there are not many of us here doing that stuff, I tried to get a formalized idea of it. So I got two tables, and this table one is a scenario table having start and end date and different scenarios. This is a situation table, table 2. And I have a timeline down here. And in the line above the timeline, I have all the periods coming from table 1, from my scenario table. And I have below that, there's all the periods I got in my situation table. I'm going to join that. And what do we expect? Well, I expect to get out all the different periods. And this is basically what I would like to see. I would like to see a period whenever there's a matching row, there are matching periods. This is from the scenario table, this is from the situation table. And whatever changes makes up a new period. So I want 1 period, 2, 3, small 1, 4, and 5. Okay? So let's see how we can get it. I try to color code it here. If you read it at home, you might I hope it helps you to figure out what this means. Well, it basically says scenario 2 is from start to whatever end. Well, the end is the red is from situation 1. So situation 1 ends, and this will end this period. Okay, so this is just some color coding in order to ease it. And this is my example where we have no gaps in between the periods. And I got a second one, and I introduced some gaps. So in that example, table 2 has situations where the next situation doesn't start when the other one ended. And even in the scenario table, there's a little gap in here. So what will we get after our join? Well, we get 4 periods in that. So again here, that's like before, whatever changes will end or open up a new period. And whenever we have matching periods, this will open up a separate period. Okay, in order to make it, in order to do this, we need to specify a certain join condition. And this is how it could work. First of all, I decided to filter out a certain business time. Business time is looking at a certain period overall. This is for business time from to. And for the join, we said from the one table, the business start needs to be smaller equals the business end, and the business end bigger equals the business start. How did I figure out that? Well, I had help in the internet. I can really highly recommend a blog entry from John Mempa. He did a fantastic article which is available on the IDOC site. It does not refer to temporal tables, but if you are if you're processing durations or periods, this is really something you want to look at. It's fantastic. And so I used that in order to learn it and extend it then for my needs. So in order to go to a real example, and my customer data was not really good enough and not good to take here, but I made up an example we all could understand. It's a little bit political in my eyes, but it is, we don't go into too much detail. I provided a table with the presidents of the USA, another table with the premiers of UK, and the Chancellor in Deutschland, in Germany, the Chancellor in Germany. And the question is, who worked with whom at what time? And for what period of time? Okay, so they all have their periods when they were elected and active. And so who met whom when they met at some whatever meeting? Okay, you got all the data in the student notes, the create table statements, and all the data is provided. So this is also will be an easy starting point for you if you want to go play around with that. So just copy it out. It's really all in there. Okay, so starting with an easy example, just 2 tables, just comparing US presidents to German chancellors. And I have the name of the president. I have a starting and business end period. And also for Germany, a name and starting and business end period. You have the president table USA. From business time, that's what we specified. We just look at the information from 1970s on, and to current date. Something to note is the correlation name is specified behind that. I tend to write it in wrong from President USA U, and for business time that doesn't work. So the correlation name has to really be at the end. So be aware of that. And we do an inner join of the Chancellor Deutschland table and same business period and the information, the where condition we just talked about. Okay? With that, let's put it one step further. Let's add UK. You know, UK has been a kind of a problem recently. It gets more complicated, so seems to be a real life scenario. No, just joking. In this case, we just add the premier again. We do the same, we double basically the conditions here. We have to double them. We do the same business time stuff. And because that gets lengthy, you could also use a min or max function for that in order to shrink it a little bit down. This is also provided in the student notes if you like to compare this to see it. But the important thing is here, besides the names, we also will return a resulting period. So all the presidents, premiers, chancellors have their own period, and we return a resulting period as well. This is the finer granularity where we get our new periods, okay? This is how you do it. You do a max of the starts and a min of the ends. And that's the result. So, you see here, the name, US, start US, end US, the name of the German Chancellor, start end, and the name of the Premier, start end. And this is the resulting period. Look at that. What has changed? Well, the last period is to end of time, starting from the 20th of January 2017. What happened at that point? Let's look at that row. Well, this was the time Trump was elected and got into action as a president of the USA. So, it does not matter what has changed. Every change will result in a new period, will result in a new row. So, that row is because Cameron changed to May. This one is there because Brown changed to Cameron. This one because Bush to Obama. And in Germany, not a lot of changes happen. Schröder to Merkel is at that point. Okay, we get all the business periods. And now it's simple. We can just read, okay, Obama worked with Merkel, with Brown in that time frame. That's what was our mission, to figure out who worked with whom, and that's the solution to it.
You created that example before end of May. Before May.
Oh, actually, yeah, that's my fault. I created it before that, but I added. Yeah, I see. I see your point. I added him. I guess I added him in the data, but I think I forgot to change the screenshot. So, okay, you pay attention. Yeah. Thanks. Yeah, end of May. Okay, that's recursive problem. No, that was last year recursion. Okay, one additional hint. I also recommend to add another where clause, where I say the max of the business starts is not the same like the mins of the business ends. Why that? Because otherwise you get time periods with a zero non-existing duration. And in order to show this, I provided some additional data. And you would get a period from 1st of 2018 to 1st of 2018, and we don't want to have this. Why that? Because the business start of the one equals business end of the other. Could happen, did not happen in my president premier example, but it could happen in other data, so you might want to exclude those. Okay? And this is how you can join them. So joining. Okay, let's go on. Why do we join? Well, we are in a data warehouse world. We do have a so-called decision support data model. We have a multidimensional data model, and this is also called star schema. You have a base fact table which holds all the data. This is huge, and you add context to it by providing several dimensions. 5 in this case, but there could be lots more in real life scenarios. So all the facts, like let's say it's a revenue, is then interpreted by a certain product. Revenue you did with a certain product at a certain time by a certain salesperson in a shop type and in a region. Okay, this is basically defined in the granularity of your fact data. The facts are always the measures, and they link to dimensions, so they are keys in the shop type, and it's reflected in the fact. Okay? It could be, besides a star schema, it could be also a Snowflake schema. It's basically the same. You just have to normalize your dimensions. This is just one example where you normalize the time dimension, and the finest granularity is always closest to the fact. It's on a level day here, and the day adds up to months, and months add up to years. Okay, so this is basically pretty much the same. You always need to link from one table to another, and you need RI or keys in that table. And while all the data changes really are usually, this is changing frequently. Each day you get new data in here. Also, the dimension could change. Like a product can change. Product names can change, and I choose one we all know. It changed from DB2 6000 to DB2 with a capital B at the time to a universal database, and back to DB2 with lowercase b. This UDB, LUW? Well, no, universal database it was called at one time. Yeah, well, okay. Yeah, well. Okay, so there are some decisions you have to make doing such a data model. Am I interested in changes of dimensions? If you're not, you don't need to historize them. It gets a lot easier. If you want to stick to reality, and most customers and most scenarios, really you need these so-called SCD Type 2 dimensions. This is slowly changing dimensions, SCD Type 2. Even dimensions can change. Names can change. Locations of shops can change and things like that. And if you want to reflect that, you have to historize your dimensions as well. Okay? So that's basically the story. But we need a key. So in that case, we say, well, this is DB2. That's key 1. And the naming depends on whatever, on that period. Okay. So what does it mean? Well, I have to link it or to use it when I join my fact table to my dimension table. This is my dimension table. And let's say in 2016 we get that amount of sales or whatever it is. And this is the link, the key to my a dimension table. So it will find 4 rows. So we have to use the date of the fact in order to figure out which is the row and what's the description or the real name of the product at that point in time. Okay? Doable? Would work? Right? So let's look at the SQL statement for that. From fact table, inner join product dimension for business time from fact date to current date. Just cut out the period you really need. And you run into this. No. Error does not work. Why not? Well, it is not expected to have a column name in here. Damned. Didn't know that. It's not yet implemented. You can provide concrete dates. You can provide current date, something like that. But you don't. You are not allowed to provide a column name. It won't work. My idea did not work here. So what did I do? Well, like IBM tells us, do an RFE, do a aha idea. And what I tell you, please go and vote for it. It really matters. Okay? If you want it simpler in future, vote for it so they will consider it maybe in future. Okay? So what's the workaround? Well, you have to do the time matching earlier in your process. And that is what we did. So we basically did not just have one key for each period. Each period of the same product gets a different key. Because we did the time matching up front. And once we load the data here into the fact table, we look up the right period at that point, look up the key, and write it to the fact table when we load our fact table each day. So it's just pushed a little bit earlier in the process. So now what we have is our join is now not on a column, on an integer column and some matching of time. It's just the integer column. So this is quite efficient, right? Because we had all the effort of the matching process and anticipated earlier in our process. This is where we get more speed. Cool. Okay, so that's a workaround. Again, some explain for those of you who like explain. And I wanted somehow doing a select, this additional subselect show up. So what's that? Didn't expect that. Where does it come from? Well, this is basically just an early out for non-matching periods. It just checks the period. Is the period definition okay? If not, don't return anything. Kind of strange. Well, they did it. Yeah, interesting stuff. Let's jump on. So, now we want to provide a BLU table for our decision support system in order to get the maximum speed out of it. And we want time travel. And there was a problem for quite a time because we did not have support for temporal and BLU until 11.1.3.3. This is when we got a certain kind of support. And the certain kind of support is like they provided the first step of it. And they said, well, we do a user-maintained thing. We allow you to run time travel SQL statements. We allow you to define the structures, but you have to handle the complexity by your own. Well, basically, by your ETL system, you're doing ETL processing anyway. So this would be the first step. I hope they go on, but this is the first step. So queries are routed automatically to the history table. This means time travel SQL is really working, but the maintaining of the history table is done by your jobs in the ETL system. Okay, so this is what we got. What did we do? Because we started with our architecture and idea before that, before I knew that. So what we did is we provided a row-based layer in the data warehouse. You know, you have lots of layers like a staging area, a main data area, data mart area, and so on. And we call it distribution area where we build our KPIs, and this is row-based. With the row-based, you have full functionality of temporal tables. And then we introduced just another organizational layer, which is BLU, and we just pump data up with a simple load, just do a one-to-one copy without logic. So from row to column-based, so I got it column-based, I got my system time and business time in here, and it just gets pushed up. That's it. That could be a solution. But now, with the new functionality of the user-maintained stuff, and this is the statement for that, so a little more syntax examples for that stuff, it says it really forces you to specify maintained by the user. Okay, makes sense to me. Also, I know some customers running a load with the option non-recoverable and wondering afterwards why the table is not recoverable. Yes, but well, this is you have to specify that. So you can also do a bi-temporal one. You have to specify it maintained by the user twice. And even doing the versioning, this is keeping the base table and the history table together. So the marriage of the two basically is doing a user versioning. User means always it's your responsibility. You can do this. So now I have to decide which way to go. Do I want to change what I have in order to get time travel SQL? Oh yeah, I want time travel SQL statements. Thank you. Or do I stick to my old traditional approach and I do all the SQL temporal coding myself from querying my data? On the other side, the temporal fact time dimension join is at runtime, including the time matching will be more expensive. Well, our workaround turns out to be really good and even from a performance point of view better. So I like that one for a performance reason. And something you should ask, depending on the front-end tool you've got, is my front-end tool able to handle time travel SQL statements? We tried that with Cognos. It worked because you have kind of a pass-through stuff where you can run native SQL statements because it's not that common, the time travel SQL. You might want to check that as well. So maybe we will end up with a mixture because I could mix these two ideas. I could enable the user maintain stuff, but doing my join up front to avoid my temporal matching. So I get the functionality of the time travel SQL, which I really would like. Okay, so this I might end up in this compromise. Something else I experienced is I love doing comment table expressions because they make SQL statement so much more readable. So this tab 1 is a bi-temporal table, and I just selected something from it, and I thought I could just run now a select from that CTE for business time from to, but again, I ran into an error. It's not clear if they forgot about it, so I open up an RFE again. This is the RFE, and again, please vote for it. We will get more flexibility, and it helps to structure SQL statements, right? Okay, so there are some challenges, but there are solutions, there are workarounds, and basically the idea is it really covers a lot of complexity. I have seen other projects doing the time generation or the historization operators they used, programmed in C, programmed in any ETL tool, and I've seen some that had 5 tries until it worked more or less good. And I said, well, I will rely on whatever provided by IBM because this is already tested and this is enough. I don't want that complexity. It's complex enough to understand it, to figure it out how it works, but it is a solution, so we will use this in our new project. There are lots of additional stuff you might want to look at. Matthias Nicola has some excellent presentations about that topic. He's around here, so you could speak to him as well. These are the most recent ones. I would like to encourage you to look also on Db2 COS stuff and presentations. They are one step ahead of us on the LUW side, because they also use the system temporal tables for catalogs to figure out changes in the catalog and stuff like that. Really cool stuff. If you like that, open up RFEs or vote for mine. I got some additionals out there. And there's also from the content block on the IBM's on the IDAC side. Even our conference chair, Phil Nelson, had done a blog article there, and also could Struth, both are around here. If you like SQL statements, I really highly recommend the Having Fun with SQL tonight. It is really fun, so join them, and you will you know Kurt Struth afterwards because he's doing that. So there's a lot more out there. Go get it, use it, and I will open it up for questions. Yes?
The problem with a common table expression, does it also hold for select, which is select from select? Does it lose the temporal information?
I don't think so. I'm not 100% sure, but I don't think so. I have done... No, I think this would work. So I'm around the whole conference. I'm happy to discuss any of the data warehouse stuff or other stuff. So just come and talk to me. And thanks for listening. And I hope you will have another successful project and keep on using the temporal stuff. It's really cute. It's really good. Thank you very much.